Hello and welcome to another screen grab style frequently asked questions console training video. First of all, before we really dive into this video as a whole and talk about what it will be focusing on and actually sort of diving into it as a whole. So first of all, my name is Charlie. I'm a freelance lighting designer, programmer, and technician. And this video is focusing on how to rectify a problem with a pre-existing fixture profile that already exists in the fixture library of EOS. This will basically cover all bases up until the current point onwards. I mean, I can't see this changing anytime soon. Certainly legacy versions of EOS operate in the same way, so we're going to this really should cover all bases regardless of what software you're currently running in terms of versions. So let's go ahead and just dive straight in. So this video will be focusing on those strange and unusual times when something isn't quite right with the fixture profile of the fixtures you're using that are in the desk. It does happen from time to time, and it has happened a good few times in my life. And we're going to use a real life example to demonstrate this. So here I have, as you can see, 4 fixtures in augmented. That's the only things that's actually patched into this show file. So these are the moving heads that we'll be using for this demonstration. So before I go ahead, I just need to make absolutely clear what this video is actually about. So if, for example, the show file doesn't quite match up with what the fixture profile on the desk doesn't quite match up with the fixture profile in the fixtures in reality, then of course we need to know how to fix that and how to get to the settings and what to change and the menus we need to go to in order to change what we need to do. As context, I'll be using the 4 moving heads that you can currently see in augmented here. They are obscure fixtures, and they're fixtures I've used in the past, and they actually still, to this day, have a problem with the fixture profile in EOS. So these are moving heads, simply put, moving head LEDs by a very obscure company called Fine Art. Now, Fine Art was, I think they've gone bust now. I don't really know if they're still functioning, but Fine Art was a Chinese lighting manufacturer and made kind of like budget-friendly fixtures back in the maybe 10 years ago, something like that. They also made some what you might refer to as clone fixtures, with fixtures that looked remarkably like the Claypaky BI and Sharpie. They're just one of those small factories that pump out these fixtures, although they did create some unique ones, such as these, which were sort of affordable, what you might refer to as sort of relatively stage usable LED moving heads. And this was very early LED technology in regards to stage. So, you know, we're talking quite far back now in regards to LED stage technology anyway, in those sort of terms. But these had a problem with them in that the fixture profile in EOS didn't match the fixture profile of the actual fixtures in reality. And what was wrong was when the fixtures were at full from the desk. So if I grab them at the moment and I put them at full, of course, as you can see in augmented, the desk thinks that they are at 100% intensity, as you'd expect. And when I take them out, the desk thinks they are at 0% intensity. But in actual fact, on stage right now, I would see them at 100% intensity, and when I put them at full, they go to 0% intensity. So they do the complete opposite of what they were supposed to do. When you look at the instruction manual, you'd find out that basically all this is, the DMX values were the complete opposite. They were the inverse of what you'd expect. So 100% intensity was represented with a DMX value of 0, and 0% intensity was represented with a DMX value of 255. Those with DMX theory would know that usually that's the other way around, because the higher number means a brighter light. That would usually be the way it is, but it's the other way around. It was simply the higher the number, the lower the light, the lower the number, the brighter the light. And of course, quite rightly so, the desk was treating it as per normal. So we need to rectify that. So what we're going to do is we're going to hop over to our other display. And this is a touchscreen, so anywhere I tap, you'll see a little white circle pop up. As you can see, OBS there recording everything for us. We're going to just minimize that. So, first of all, I'm going to assume that you have a baseline or basic understanding of EOS. So, first of all, if we just navigate to Patch and enter the Patch tab. First of all, before we go any further, there are two things we need to make sure that we have done before we can actually get into the display we want to enter. We need to make sure we are in the patch mode over here. If we're in attributes or database or any of these other things, we need to make sure that patch is selected. Now, this may look a little bit different if you're running 2.9.2 or prior, but the same sort of principle applies, okay? So all in all, you just want to make sure patch is selected. It may look a tiny bit different, so that you've got on the right type, label, channel address, interface, all of that's on your right here. The next thing you need to do is clear your selection. And you do this by simply clearing out the command line. So for example, making sure that anything at all, there's nothing highlighted. As you can see, I've got a channel 12 is highlighted in yellow. That is selected. I've also got channel 12 on the command line. I'm going to clear that out using the clear function. Or if you want to be doubly sure, you can hold down Shift and press clear. Once that's done, we now get the soft keys that we're looking for. In the bottom right, you'll see the soft keys. We have query, fixtures, and properties. That's 4, 5, and 6. We want to navigate to soft key 5 or fixtures. So you can click on that, tap on that, or press soft key 5. And we get the most daunting and intimidating spreadsheet known to mankind. So we are presented with this menu screen, and I know quite a few people may not have ever entered this far into EOS before, maybe not even seen this menu screen before. But I'm going to break it down so it's easy to understand. On the left-hand side here, this table shows each individual fixture profile that is in use in the show file itself. This does not show each individual fixture, just each individual fixture profile. When we have selected one, so dimmer for example, this table will outline the amount of parameters and the DMX values and attributes associated to that in this table here. Of course, we've got dimmer selected, which is locked in because that's baked into the desk. And that is, of course, a single DMX channel. There we go, 8-bit. With ranges 0 to 100%. Perfectly easy to understand. Of course, we're going to navigate to our defective fixture, the one that we need to modify. Now, in this instance, as we said, we're looking to fix the intensity. So I'm just going to quickly break down everything we have here. We have the DMX footprint and the parameter count up here. The reason these are different is DMX footprint simply outlines the individual DMX parameters that are in the fixture. The parameter count includes the virtual parameters that are put in place by the desk and are not in any way associated to the fixture directly. What I mean by this, a prime example is hue, saturation, and brightness. We use these three parameters on all color mixing fixtures, and when we modify these, they alter, in this case, red, green, and blue. So they control a real parameter. As you can see, that's real, a virtual. We have this hashtag here simply lists each parameter count, including virtual, we have the parameters themselves, the category in which they are put under, i.e. color, form, focus, etc. Of course, this is quite important if you're making a fixture profile and understanding that, because depending on what category it is under depends on how the desk will treat that parameter, i.e. in palettes or queue timings. The next one along, we have DMX. This will list it as either virtual or not, and if it's not a virtual parameter, we'll end up with information as to whether it is 8-bit, represented by the 8B, or 16-bit, represented by the 16B, along with the DMX channel of that parameter. You'll notice that 16 bits have 2 each. That, of course, is because it takes 2 8-bit sets to make up a 16-bit. And when we double-click on this, we can see that in the case of pan, which is a regularly 16-bit parameter in the world of DMX, you may recognize pan and pan fine, tilt and tilt fine. This is to allow for the fine-tuning, that accuracy that moving light fixtures require, especially in theatre when they're projecting onto a subject. Getting the accuracy is very, very important indeed. And in this case, we have pan as DMX 5, and pan fine is DMX 10. We then have home. This is very simple. This is the home value of that parameter. We then have snap, either on or off. So snap functions are things like macros, things that don't need to flow or have a fluid motion to them, like red, green and blue. That, of course, we need to control fluidly from 0 to 255 to 0 to 100%. But things like macros, we don't control those fluidly. We control those by pressing a button. There's either yes or no kind of basis on each of the macros. So that is that's a snap. Another example might be a snap color wheel or something like that. We then have the ranges. The ranges control, or rather store, all of the more important information, i.e. the ranges for the pan and the tilt. Let me give an example of that. So there we go. When we double click on that, this is pan. We can see the DMX value that the desk sends out to the fixture in order to control the pan. This may seem rather confusing because, as we know with our DMX theory, it can go from 0 to 255. So why on earth do we have this ludicrous number here? Well, that's of course because this is a 16-bit attribute, and thus we have 2 DMX channel sets there, 5 and 10. So that's those combined there, along with the home. And then we have user. These are the ones that we see in ML controls. These are the things as programmers that we use as human beings. So in reference, we have minus 270 degrees, 0 and 270 degrees is likely what it will come up on the ML controls there, as well as a quick label there. Another example of snaps might be, here we have the shutter strobe. And as you can see, this is all nicely labelled, and you'll begin to see some kind of synergy appear between ML controls and this screen here. So, for example, random strobe. There we are. There's random strobe. That's DMX values from 192 to 255. And the label on the button inside of ML controls will be RND+. Which, of course, we all may recognise as random plus. And then, of course, we can see the user values that are associated to that as well, which, of course, don't need to be too distinguished because, of course, we have pulse over, and random, etc. Just depends how they put it together, really. Anyway, now that I've broken that down, hopefully, depending on what your issue is, you'll be able to navigate to the parameter you need to fix. In this instance, in this example, it is the intensity that we need to fix, and that is represented as intense, which is here, and that is showing up as DMX channel DMX control channel 12, and we have it as parameter 10 on there, and we can navigate to the range, because in this instance, if you remember, the problem is 255. Instead of representing 100%, it actually represents 0%, and 0, as in the DMX value 0, represents 100%. So it's complete inverse to what it should be, but the desk doesn't know this, so we double click here. And yeah, as we thought, if we look on here, 0, 255, 0, 100%, as you'd normally expect with 99% of every other fixture on the planet. But of course, fine art had to be different. And so what we need to do is very simple, is we need to swap these values around. So I go minimum 255 and maximum 0. And now we have the opposite of what we were expecting. It's very simple. Now, EOS has tried to be friendly here. It isn't always friendly. And has tried to compensate for what we're trying to do. So I'll do my best to do that. Hold on a minute. Actually, oh, okay, this is a good point. We need to try and... the other thing that this just caught me off guard here. If I set home as 0, then it would be at full. We want to set the home as 255. Let's do that. There we go. And the user home position as 0. That's perfectly what we're after. That's what we want. Okay, so now what we will find is when we type in channel 1 or whatever it may be, channel 1 at 0 here, it will send out 255, meaning go to 0% intensity. And then when we type in channel 1 at 100 full, or 100 enter, or at full, it will send out the DMX value 0, which in this ludicrous example means go to full. So there we are. As you can see now, that all matches up as our example shows us. We can then jump out of that display. Now, before you leave patch, it's very important you do this. You get 2 little pretty buttons in sort of the mid right here, save and cancel. If you cancel or don't save this, then the desk is going to ignore everything you've just done. So we're going to hit save here. Once you press save, those buttons will disappear. If they are present, it means that something hasn't saved or a change has been made that hasn't saved. Once you have modified a fixture profile, you will see an asterisk appear over on the left there. When we drop this down, we will also see the asterisk appear in front of all the types in the table. And if I jump into live, we should be all good. Now, if I quickly get our screen over to augmented, just as an example there. Okay, so very, very distinct example. Now, when I press out, the lights on the stage will go out. When I tell them to go at full, the lights on stage will actually go at full, because we've inverted the DMX value as it says in the instruction manual, which it didn't have in the pre-made fixture profile that was already in EOS. This still exists in EOS to this day as an issue, though I don't think anyone will be particularly in any rush to buy the fixtures in question. They're very strange. Anyway, all in all, I hope this will help someone in finding the problem that they are... oh, hold on a minute. There we go. I hope that this will help someone find the problem they are looking for, and also give them the confidence in order to fix it. So just remember, any one of these parameters or each one of these things that you see in the demonstration today, and what I mean by that is, let me flip my screen over. There we go. Any one of these things, so the parameter itself can be changed. I'll show you that. All you need to do is double click and you can search by type or you can simply type it in. You can actually change the bit or the actual value of the actual parameter itself in DMX. Effectively, everything is up for grabs in regards to changing things. In a future video, I do plan on showing you how to make a custom fixture profile from scratch in EOS itself, and it's very much along the same lines. But either way, this hopefully will fix a problem for someone out there, and that is all I hope to achieve. Anyway, there we go. My name's been Charlie, and this has been a little video on rectifying pre-existing problems in the patch of EOS. If you do have any questions, whether that be console related, lighting tech or lighting maintenance related, or if you have any questions or anything you want to see discussed here in regards to lighting design, then you can pop it in the comments below and we will discuss that. I don't necessarily have to do a screen grab style video, it could be anything. So that is something you can do if you want to talk about lighting design for dance, lighting design for theatre, lighting design for events, things like that, whatever it may be. Anyway, I hope this has been of value to you. Thank you so very much for watching, and I hope that this video has been in some way useful to somebody. Anyway, ta-ta.